These are the solutions to the final exam, Math 222. Okay, number one, the constant of -4 gets moved over to the right-hand side. So x squared minus 4x plus y squared plus 2y equals 4. Complete the square. Half of -4 is -2, square root is 4, add 4 to both sides. Half of 2 is 1, square root is 1, add 1 to both sides. X minus 2 squared plus y plus 1 squared equals 9. So the center is 2, -1, radius of 3. Number 3, trying to find f of x plus h minus f of x for this function. So 3 times parentheses x plus h squared minus 4 times x plus h plus 2 minus parentheses 3x squared minus 4x plus 2. This is 3 times x squared plus 2xh plus h squared minus 4x minus 4h plus 2. Distribute the minus sign, minus 3x squared plus 4x minus 2. This will become 3x squared. That cancels that 3x squared. -4x cancels out positive 4x. Plus 2 minus 2 cancels out. So we're left with 6xh plus 3h squared minus 4h after distributing. Number 3, at rest means set the velocity equal to 0. -5t squared minus 5t plus 100 equals 0. Factor out to -5. T squared plus t minus 20. This factors in t plus 5, t minus 4. T equals -5 is not possible. Time is positive. So t equals 4 seconds. Number 4, find the domain of g minus f. It's radical x minus 3 minus radical x plus 2. So both x minus 3 has to be greater than 0, and also x plus 2 is greater than or equal to 0. This means x is greater than or equal to 3, and also x is greater than -2. Well, any number that's greater than or equal to 3 is automatically greater than or equal to -2. So it's just enough to say this one right here, or bracket 3 comma infinity. Number 5, the main difference is that you're not allowed to plug in 1 here, but you're allowed to plug in 1 here. You can reduce this to algebra to this, but in the original, x is not allowed to be 1. Okay, so f of 1 does not exist, d and e does not exist, but g of 1 does exist, it's 2. Okay, otherwise, they're the same because f of x equals x plus 1, x minus 1 over x minus 1. After cancellation, you get x plus 1. Okay, a function which is not 1, a function which is 1 to 1. Okay, this one is not 1 to 1, so a function which is 1 to 1 would be something like that. Sorry, I made a mistake. Draw a graph of a function which is 1 to 1. Okay, so it has to pass both the horizontal and vertical line test. So what I had originally was not correct. It asks for a function which is 1 to 1. Okay, 7, f of g of x. G of x is this. So f of 2x squared plus 1, 4 times 2x squared plus 1 minus 5, 8x squared plus 4x minus 5, 8x to the 4th minus 1. Okay, number 8. You know the zeros are -2, 1, and 5, all of multiplicity 1, so you know the graph is going to cross the x-axis. Okay, when x goes to infinity, y goes to infinity. When x goes to negative infinity, y goes to negative infinity. How do you know? Well, if you plug in a super big number, you have a positive times a positive times a positive, which is positive. If you plug in a super big negative number, it would be a negative times a negative times a negative, which would be negative. Okay, so that means I know over here, it goes like this. Over here, it goes like this, and it always has to cross. So cross, cross, cross. So that's a rough sketch. Number 9, you're told that -2 plus 4i is a solution. They always come in conjugate pairs. So -2 minus 4i is also a solution. And by inspection, you can tell right away that if you plug in 1, you get 0. 1 plus 3 plus 16 minus 20 is equal to 0. So the solutions are 1, -2 plus or minus 4i. Number 10, you have 200 feet here. Angle of elevation is 23 feet. The height is x. So tangent of 23 degrees is x over 100. X is 100, tan 23 degrees, approximately 42 feet, rounded to the nearest whole number. Okay. Number 11, the cosine of theta is negative radical 3 over 2. Okay, so the x-coordinate is here and here, which means the y-coordinate is a half and negative a half. That looks like 5 pi over 6 and 7 pi over 6. Number 12, sine x plus cosine x equals 1. Subtract cosine x on both sides, square both sides. So sine squared x equals 1 minus 2 cosine x plus cosine squared of x. Change sine squared x to 1 minus cosine squared x. Subtract 1 on both sides, they're gone. Add cosine squared x to both sides. 0 equals 2 cosine squared x minus 2 cosine x. Factor out 2 cosine x. 2 cosine x times cosine x minus 1 equals 0. This says cosine x equals 0 or cosine x equals 1, i.e. on a unit circle, x coordinate is either 0, here or here, or 1. That gives me 0, pi over 2, 3 pi over 2, and 2 pi. However, 3 pi over 2 does not check with the original equation. If you plug in 3 pi over 2 to the original, it does not check. Okay, you'll end up with -1. So throw that one out. 0 does check, pi over 2 checks, and 2 pi checks. So my solutions are 0, pi over 2, and 2 pi. Okay, number 13, take the natural log of both sides. So if you take the natural log, x minus 4 comes down in front like this. And ln of e to 3x is just 3x. Distribute x ln 2 minus 4 ln 2. All right, subtract 3x and add 4 ln 2. So add 4 ln 2, subtract 3x. Factor out the x. This is ln 2 minus 3. Divide both sides by ln 2 minus 3. So x is 4 ln 2 divided by ln 2 minus 3. It's approximately negative 1.2019. 14, ln something minus ln something means I can write ln of a quotient. So ln of 2x minus 1 over x minus 1 equals 5. Exponentiate to get rid of the ln. So you have 2x minus 1 over x minus 1 equals e to the 5th power. Multiply both sides by x minus 1 to get rid of the fraction. 2x minus 1 equals x e to the 5th minus e to the 5th. Subtract 2x on both sides and add e to the 5. Get all the x's on the right side and everything that doesn't have an x on the other side. So it looks like this. E to the 5th minus 1 is x times e to the 5th minus 2x. Factor out the x. Divide by e to the 5th minus 2. So the exact answer is e to the 5th minus 1 divided by e to the 5th minus 2. It's approximately 1.00683. Okay. 15, doubles every 15 minutes. So that you start off with a 100. Double is 200. Time is 15. Divide by 100. ln 2 is e to the 15k. Take the natural log of both sides. And so ln 2 is 15k. Divide by 15. K is ln 2 over 15. It's about 0.0462098. Okay, then go back on top. Plug that in for k. So a of t is 100 e to the 0.0462098t. Okay, so now it says, when will the population be 5,000? Put 5,000 here. Start over again, divide by 100. ln 50, just 50 is e to the 0.0462089t. Take the natural log of both sides, that cancels out. ln 50 is 0.0462098t. Divide by 0.0462098. You get about 84.66 minutes. Okay, 16, vertex is -2, 2, focus -2, 4. So here's -2, 2, here's -2, 4. Okay, the focus is always on the inside of the parabola, so I know it opens up. So if this were vertex at the origin, it'd be x squared equals 4py. Okay, I know p is 2 because the distance from the focus to the directory is 2. So it's going to be x squared equals 4 times 2 is 8y, and then translate over 2 to the left and 2 up. So the final answer is x plus 2 squared is 8 times y minus 2. Okay, 17 is another complete the square. So put the x's and y's together. So put x squared with a minus 2x, 4y squared and a minus 16y. Factor out the 4. Put the 13 over on the other side. So x squared minus 2x plus 4 parentheses y squared minus 4y. Half and square, add 1, add 1. Half and square, add 4, which is really 16. X minus 1 squared plus 4 times y minus 2 squared equals 4. Divide by 4. X minus 1 squared over 4 plus y minus 2 squared over 1 equals 1. This should be a 2. So I think I made the same mistake as before. This should be 2. This should be 2. This should be 2. This should be 2. Okay, so the center is 1, 2. A is 2, B is 1, C is radical 3. Foci are 1 minus radical 3, 2, and 1 plus radical 3, 2. And vertices are -1, 2, and 3, 2. Center's at 1, 2. Okay, finally, 18, focus is 2, 2. Vertex is 2, -1, and 2, -3. That makes the center at 2, -1. It's opening up and down, so y comes first. Y plus 1 squared over something, x minus 2 squared over something with a minus sign. A is 2, c is 3. Use a squared plus b squared equals c squared, and b comes out to be radical 5, so b squared is 5. So y plus 1 squared over 4 minus x minus 2 squared over 5 equals 1. Okay. Question 19 and question 20 are freebies. Pretend there's a question 19 and a question 20, and you automatically got full credit on those two problems. All right, so that's the end of our class, Math 222. So hope you enjoyed the class. Hope you have a good Christmas season and happy holidays and a happy New Year.